In the next three videos, what I am going to talk, a lot of it is not going to be understandable to you at this particular level of your learning. The reason being, you are expected to learn maybe two or three programming languages, have some experience in computer science, and then you shall understand what I am talking. So, for these three lectures, just try to remember what is told. I'm almost certain you won't understand more than 50% of what I am trying to tell, but that is okay. The whole idea is to just hear these words, understand them as much as you can, because in computer science, you gradually learn things, but some points need to be introduced so that they make sense when you're learning them. Let us say I want to develop an application for my university or for my school. So for the first step, if I have to develop an application is I have to gather the requirements or the specification from the university or college. Let us say I want to automate my PU college. I want to develop one software for the admission, one software for maintaining, keeping track of the fees, one software for managing the automation. So once I get that requirement, I need to analyze or understand the problem thoroughly. So once I understand what is the problem, I need to, in the problem analysis, I need to understand what programming language I need to develop in, what is the hardware, what is the software, what exactly are the requirements of the users, how are they doing it currently, how it can be done using computers, what can be done, what cannot be done, and so on. So once you analyze the problem, you break it down into a number of parts. Then for each of the problems, you design the appropriate algorithm, pseudocode or flowchart. This is done so that the people who can code it are able to understand the logic or based on the flowchart or algorithm are able to write the code. So once you design the algorithm, flowchart or pseudocode, they can proceed to coding that particular thing in the language the application is going to be developed. It could be C, it could be C++, it could be Java, it could be Fortran, COBOL, or any other things a decision has been made on. Now, once you have coded, it cannot be directly used because there may be a lot of errors in what you have developed. So, what really happens is a process of testing is done by the people who wrote the code as well as end users. So when the testing occurs, the number of errors discovered are reported. You are required to debug and correct those errors. Once the debugging of errors is done and the application is found to be stable and suitable and it is able to manage the functions for the university, what I do is I start at the same time developing the documentation. Why do I need to develop documentation? Documentation needs to be developed so that people who need to use that application can find some notes how to use it, how to manage it, how to administer it, how to make changes into it, what are the different programs, what are they doing, and so on. So once the documentation is done, then you deploy it. This is called implementation. That means it is put into use. And once it is put into use, there will be changes because of legal requirements. There will be changes because of bugs. There will be changes because of business reasons. So you will be adding code to that particular application. So that is known as maintenance. So this summarizes or gives you an idea about this section, gives you an idea about what all we end up doing or what is the life cycle of a computerized process or application. Now if you look here, there are various approaches or methods of solving a given problem. Let us say I have to build a home. I'll go to the architect, get the plan from the architect, hire engineers, then I'll break down the building of the house into a number of parts like foundation, then the slab, then the painting, then the flooring and whatnot. So similarly, there are a number of approaches to problem solving. The two common approaches are top down and bottoms up design. Top down means you get the requirement or the problem at your hand, then you break down the problem into a number of smaller parts, find the solution to the smaller parts, combine the solution so that it gives you the solution of the entire system. So think of it like this. Let us say I am developing software for your college. This is A is the complete problem. I break it down into this is admissions, this is exams, and this is maybe something time and attendance or whatever it is. Again, within admissions, I may break it down into two parts. Okay, PUC admission, degree admission. Then D can be some other part can be broken into G and H. So this is taking a big problem, breaking it into number of small parts. Still, that small parts can be completed or coded as simple programs. So a problem is repeatedly divided into a number of small problems. This process is continued to be repeated till the small problem is equal to the level of some program, or you can write a code for that. Now, what are the advantages of a top-down programming approach? Generally, when humans get a problem, they look at the problem and they try to solve the problem by using a divide and conquer approach. So same here, we try to divide the problem into a number of sub problems, break it down into details, and then divide the problem and hand it over to different people to solve the individual parts. So programs can be developed independently and quickly by different people with minimum errors. Another advantage is when you break the problem into a number of parts, different people can develop solutions to different parts in parallel. Now try to understand what is bottoms up design. Bottoms up is exactly opposite of what is top down approach to problem solving. Here what we do is we first try to look out or analyze all the details. We find a solution to the details. For example, my detail could be finding the square root, finding the logarithm, calculating the length of a string. So you can think of all of these details. Then in order to, it's like taking spare parts and building the complete bike or car. So I make a list of all the spare parts or details are required. Then I combine all the parts or spare parts so that I'm able to find the complete solution to the problem. In bottoms up approach, more than likely you will not write every piece of code. You will try to borrow code from existing library, or if it is already available as a software package in the market, some small part may be available, so you may assemble them, join them. So you will try to source from library or develop the small parts, combine them to find the solution to the problem. But the problem with bottoms up design is it is extremely challenging to identify all the low level tasks or details at the beginning. The details generally become clear as we proceed to implement the project. They never are clear at the beginning. So as you begin to jump into it, you begin to understand the details. So the details become clearer as we proceed to solve the problem. But bottoms up design is an example which is used in OOPS or object oriented programming. So in this mini video or a micro video, I just talked about what is the approach to developing an application starting from requirements gathering to maintenance. And the next, what are the common approaches to problem solving, the bottoms up and the top down approach. Just try to remember the diagram, just try to remember the points as much as you can, because I have put it in simple words so that you can understand. But it's going to be extremely hard to make sense of this till you write programs and implement projects. That will happen only when you write some application software or work in an industry and so on, or maybe when you go to engineering and learn software much more in depth.